Welcome to the second half of this talk about bass reflex alignments. We will start now to talk about Richard Hubert Small. He is from San Diego, but he went to Sydney, Australia to write his PhD thesis, which came out in 1972 on loudspeakers, and he stumbled upon the work by Thiele. Richard Small wrote articles for the Journal of the Audio Engineering Society, starting in 1969, as far as I remember, and continuing with a four-part series on vented box loudspeakers in 1973. These articles created a lot of interest across the world, and essentially within a few years, loudspeaker manufacturers were documenting their drivers with Thiele Small parameters, such that engineers could sketch their designs prior to buying the driver, and not least identify which driver was most suitable for their desired target response. Thiele did the groundwork with the idea of alignments, and the work by Small put it into practical use worldwide. Thiele once told me when he visited the Scanspeak facilities in 2009 that he decided to publish his two articles with an Australian publisher to give Australians a leading edge. Well, since the papers were largely ignored until the work by Richard Small, this didn't work out. I also have a suspicion that the reason could be a different one. For example, just that, it wasn't so clear-cut who to use when you publish papers, and there were more options back in the day. And my colleague at Scanspeak, Knud Thorborg, he once told me that they received Thiele's IRE articles at the Peerless factory on Amager in Copenhagen. The engineers at Peerless were quite interested and they tested the theory, but for some reason it didn't work. And Thorborg speculated that the reason it didn't work for Peerless drivers around 1961-62 is because they were using open weave dust caps, meaning that air could penetrate through the dust cap and creating a lossy designs. And at the time, before hi-fi, the dust caps, indeed, they were just there to prevent dust from entering the magnet system. Later, dust caps were sealed and air pressure had to be relieved from between the dust cap and the pole piece underneath, which at Peerless they do by putting holes in the diaphragm. Other designers, they vent through the magnet system. There could be other reasons why there were discrepancies from the theory by Thiele, but I think this is the real reason why Thiele's work didn't pick up from the beginning, simply because the world wasn't ready for it yet. Fast forward back to the 1970s. A third name sometimes shows up, which I would just like to mention shortly, and that is John Ernest Benson. He was born in 1911 and he died in 1989. He was also associated with Sydney University, and he wrote a three-part series of articles printed in 1968, 1971 and 1972, which became an entire book named Theory and Design of Loudspeaker Enclosures. Benson was the examiner of Richard Small's PhD thesis, and Benson's work was quite comprehensive and maybe a bit pedantic in his approach. And personally, I think it was the work of Richard Small that presented a design method which was accepted worldwide. In the mid-70s, Siegfried Linkwitz described an electrical filter named the Linkwitz-Riley filter. It's named after himself and a colleague named Ross Riley, where two second-order Butterworth responses in series, so-called cascaded filters, like we talked about before, you take two polynomials like that. Each of those two polynomials have a Q of 0.707. So they're Butterworth responses. And they are identical. This article was published in February 1976. But my point is there is no base reflex alignment named the Linkwitz-Riley alignment. And when it comes to base reflex alignments, I would like to mention William Hoge, because he described what he called the Boombox alignment, or the BB4 alignment. He also cascaded two identical second-order filters. And Hoge's description of the Boombox alignment is from October 1976, so 8 months later. Hoge doesn't work with low QT drivers. In fact, he proposes the Boombox for high QT instrument speakers. And therefore this response will always have a peak before it rolls off. And the idea to extend the Boombox alignment for lower QT drivers is the work of Robert M. Bullock III. And this extension is called the sub-Boombox, or SBB4 alignment. He described it in Speaker Builder magazine in 1981. And in principle, just to explain that there exist good base reflex configurations that are not described by classical alignments. If you choose your parameters correctly, the Boombox/sub-Boombox alignment, it will be the base reflex equivalent of a Linkwitz-Riley filter. You get in the ballpark if you choose the driver QT around 0.36, 0.37, thereabouts. And it's in a design including losses. In similar ways, Bullock also shows the SC4, the so-called sub-Chebyshev fourth order, which was previously described by Thiele, as well as the super QB3, whereas super is not super good, but it means that the QT of the driver is higher than what you would choose for a B4 alignment. So we are above QT of 0.4. So he extends this QB3 to higher Q value drivers, and it becomes SQB3 or super QB3. And because the Q value is like it is, and it's not a linear alignment, it's not linear in frequency response, but it has ripple. So regarding these alignments, I once had a demonstration by Ulrik Schmidt, who worked at Scanspeak at the time, and I was working at an audio, by the way. And it was a presentation for the Danish Electroacoustic Fellowship, or Electroacoustic Society, something like that. And there were many people in the room, and Ulrik had designed 3 boxes, each made with a similar driver, but they were tweaked for different QT values, so that he could align them exactly with a C4 alignment, a Chebyshev alignment. The B4, which is this discrete alignment, you need very specific QT to do that, and the Bessel alignment filter function. So we could clearly hear the difference in sound quality, and it became immediately apparent that the C4 alignment sounds dark and dull and lacks detail, whereas the Bessel alignment has the best bass performance of the 3. It doesn't go the deepest, but it sounds the best. It's very impulsive and musical sounding. So thank you to Ulrik for that one. It was a great demonstration. It must have been around 2001 or something like that. When software became available in the 1990s and into the early 2000s, the designer software presented you with a drop-down box where you could select available alignments for whatever driver you had in the software. Or possibly you could choose user-defined alternative when you are on your own. In my opinion, it wasn't easy to use this user-defined box because I found it difficult to understand where and I was, in regard to alignments and what I was aiming for. So when Juha Hartikainen and Janne Ahonen were programming WinISD, this was again around 2001, maybe 2002, I proposed they should present the available base reflex alignments in a two-dimensional chart instead of this drop-down box. And in a two-dimensional chart, you would then have, alpha on one axis and H on the other. Alpha is a ratio of the VAS of the driver and the box volume. And H value is a ratio of the port tuning frequency versus your driver's resonance frequency in free air. Because it would make it clear to see where you were, but they decided not to do it. Therefore, I think Speakerbench is the first software that gives you this 2D chart of alignments, which, so for me, it gives you an intuitive feel for where you are heading. And when you do something non-conventional in the box tuning that doesn't fit an exact alignment with a filter function, you can kind of see where you are between alignments. So please go and check out the alignment chart available in the Speakerbench box simulator. The concept of alignments was a major drive for speaker builders some decades ago. But with the help from our personal computers, we can now calculate the results in the form of frequency response, impedance, time response, group delay, port output, air velocity in the port, and so on. And therefore, the alignment with the filter function is in principle no longer needed. You can just look at all your graphs and see exactly how this particular box is behaving. But in my opinion, the concept of alignment is still useful as an anchor for what you do with your box tuning. Even if the Thiele small approach is not the most accurate way to do the design, because we now have better loudspeaker models available, I still think it's a good way to look at where you are in the ballpark sense. This concludes the video. I hope you enjoyed it, and if you did, please give it a thumbs up. And if you would like more content of this type from us and wish to stay in touch, please subscribe to our YouTube channel. Have a great day.